Welcome back, and thank you very much for staying with us. I hope you guys are still enjoying the show. We also love to have a lot of information and questions from you. So please keep those questions that you've been sending to us. Remember, next week we are going to switch focus to calculus, first principle to be exact. So if there is anything that you want us to assist you with when it comes to finding the derivative from first principle, start sending those questions now. You stand a chance to win awesome prizes if you do so. Who knows, maybe you will be the next person that wins that 19-inch television. Now we're going to go to a very powerful segment. This segment is very interesting because it allows us to give you the opportunity to ask us anything across the math curriculum that is not necessarily our topic of interest on that particular week. For example, this week we've been doing the factor remainder theorem. So if there's something else that you're busy with, maybe let's say, for example, you're doing geometry, or maybe you're doing functions, or any other thing that you're doing that is not necessarily related to what we are focusing on, we give you the chance to send that question in. We call it the wildcard. So this week's wildcard comes from Monica. Let's go and check what Monica had to say. Monica?
Hi Tenfold, my name is Monica. Can you please help me with the question that states, what must be added to 2x cubed minus 5x squared minus 12x minus 4 so that it is exactly divisible by 2x plus 1? Thank you.
All right. Well, this Monica's question is a very interesting question. We are going to leave that one for last because it's so nice. We will close the show with that one. So our wildcard will just be a different question, a geometry question to be exact. But that question of Monica is so nice, we want to leave it for the last part. We'll close the show with it so that it will help us to wrap the whole factor and remainder theorem concept quite nicely. So now let's see what will happen here. This wildcard that we have is a geometry question that comes from the proportionality theorem to be exact. Let's see what it says. It says to us, there is a need to complete a particular statement that is given to us. It is a geometry statement. So grade 12s, it's very important for you to understand that in geometry, we are going to ask you in exams questions from grade 11 geometry as well as grade 12 geometry. Most of the time, we sometimes ask you to complete statements. We give you a particular statement that refers to a particular geometry question that you could be working on. So in that instance, you just have to remember what the theorem says from your theory and then complete the statement. So let's see what this one says here. Complete the following statement that says a line parallel to one side of a triangle divides. Okay, cool. So apparently there has to be a triangle here. I'm going to try and make sense of this question by drawing a triangle. This is our triangle. Let's look at the triangle again. Right, that the question says, let's call it triangle ABC, for example. It's a very simple question. If you know the theorem, you can be able to complete this quite easily. So if you don't know it, becomes a big problem. It says to us, a line parallel to one side of a triangle. So at the moment, we don't have that line. I'm going to introduce that line here. I'm going to put it from this point to that point. Let's see what will happen there. Right. So that line, if this line that I just drew, which I'm now going to call XY, let's call that line XY. If this line is parallel to one side of the triangle, then what is going to happen? Well, from our proportionality theorem, we know for a fact that that line will divide our triangle into two equal proportions. It will divide the other two sides into two equal proportions, such that the distance AX divided by the distance XB can be actually equated to the distance AY divided to the side YC. So let's see, how do we actually use that to complete the statement? Well, it's a very simple question. A line parallel to one side of a triangle divides the other two sides. It divides the other two sides into equal proportions. It doesn't mean that they are equal, it just divides the proportions of those sides. It divides the other two sides into two equal proportions. Very nice. Now we're going to go to the second part of this question. We are given a very nice diagram there, which is triangle KLM. and we are required to do a couple of things on it. Now, when you are doing geometry questions, when you are dealing with geometry questions, it's very important for you to always consider the love letter that is given to you. Examiners give you a love letter for a reason. So you must take that love letter that is given to you and translate the information that is appearing there into the diagram. You'll find that more often than not, once you have a lot of information appearing on the sketch, it becomes easier for you to navigate your way around that particular question. But if you're just going to leave everything there at the top, sometimes you miss important information that is supposed to be on the sketch that can help you to work out the question. So let's see now if we use what is given to us and try to put that on our sketch. It says in triangle KLM, angle K is 90 degrees. And when you check the diagram here, we can clearly see there that angle K is indeed 90 degrees. It is indicated right there at the bottom corner. There's our 90. We're happy with that. And then it says that and D is a point on the line KL. Right? We can see that there's point D. It does indeed appear as a point on the line KL. So that KD is to DL equals to 2:1. Now this is a ratio. We are given a ratio of two sides here. The ratio of the side KD to the side DL is equal to 2:1. So now more often than not, it becomes easier when you change that ratio and express it as a fraction in this way. You rewrite it as KD divided by DL is equals to 2 divided by 1. Right, that is the ratio that was given to us. It is further indicated that DE, the line DE, right, is parallel to the line LM. Okay, there's our line DE. We can clearly see that it is indeed parallel to the line LM as indicated on the sketch, with E on the line KM. There's our point E, which does appear on the line KM. Now, question 2.1. If DL equals X, if DL equals to X, so you have to find where DL is and try to substitute that value of X that is given to you. So if DL is X, which is right here at the bottom, I'm going to put the value of X there, and EM equals Y. Where is EM? EM is right there at the top. There's EM right there at the top, so this one is equal to Y. Express LM squared in terms of X and Y. Okay, cool. So this is asking us to basically find the length of LM. And if you check here closely, LM is a side. This LM is the hypotenuse of the entire triangle. So if I draw it, that is basically what we're asking you to work out. It is going to be the hypotenuse of the triangle KLM. So for me to do this, I'm just going to simply use the theorem of Pythagoras. But then I'm going to have problems because I don't know how long is the side KE, and I also don't know how long is the side KD. But then if you go back to the ratio that was given to us, which is currently appearing in yellow, we're told that KD is 2x. Now, it is 2, KD over DL is 2 over 1. That means if DL is x, if DL is 1x, then clearly KD will also become 2x. So, which means that this length here can actually be written as 2x. Okay, cool. So now, I'm going to apply my proportionality theorem. That says if you have a triangle, and one side is parallel to the other side, it will divide the remaining sides into two equal proportions. So the ratio on one side will be equal to the ratio on the other side. I am going to use this. And you must always know this when you're doing geometry. A lot of the questions that you deal with are follow-up questions. So the first question was there for a purpose. It kind of like gives you a hint of how to approach the following question. So now let's go into it and see how we can use that particular theorem to try and make more sense of what is happening here. So in this question, if I write that KD, right, divided by DL, it is going to be equal to that. I'm actually looking at the entire triangle using this line, the line that I just highlighted in yellow, being parallel to the other one that you see there. So it does mean that the distance KD to the distance DL will be equal to KE divided by EM. Right, that is going to be equal to KE all over EM. Great stuff. So this is coming from the proportionality theorem, right? Proportionality theorem, because we've got a line ED that is parallel to the line LM. Great stuff. So now we already know a lot of things here. Let's see, what do we know? Well, we know that KD, for example, equals to 2x. So I'm going to sub that. We know that DL, where is DL? DL is x. Great. It's equals to what is KE? Well, we are looking for KE. And we also know that EM is given by y. So clearly, you will see that the x's will cancel out here. And when you simplify here, by cross multiplying this one, your KE will eventually come out as KE equals to 2 times y, which is going to be 2y. So I'm going to put it there as the length of that missing side. Now I've got all the sides of my right angle triangle MKL. I'm going to be looking for the hypotenuse now, the red triangle. I'm looking for the hypotenuse. In this triangle, I'm going to apply the theorem of Pythagoras, which says that the square on the hypotenuse. So KL squared equals to the bottom line. Sorry, that's not KL. That is going to be LM. Sorry for that. Let's fix that. We are looking for the square on the hypotenuse, which is equal to LM. Let's see what will happen there. So LM squared equals to KL squared plus, I think this one going up is actually KM. So it is equals to KM squared. And then let's substitute the sides that we know. We have already found the lengths of those sides in terms of both x and y. The side KL is 2x plus 3x, the bottom side, which is basically simply 3x, everything squared, plus. Now, the vertical line, which is the line KM, is 2y as well as y. That is another value that can be expressed as 3y squared. When you simplify, you get 9x squared plus 9y squared, and that is the length of LM squared in terms of both x and y. They wanted the length of LM squared. They don't want you to work out LM. Just give us LM as a function of both x and y. And then we're getting that LM squared is 9x squared plus 9y squared. So let's go to the follow-up question of this. What do we know already in this diagram? Well, the follow-up question is asking us to find a very interesting relationship here. Show that dm squared plus le squared is 13 over 9 lm squared. Okay, cool. So according to this question, I'm going to go and put back what we already know. We know that this is 2y. We know that this is y. We know that this is 2x. We also know that this is x. And we just found that the length of this big side here is basically 9x squared plus 9y squared. This is the length of the hypotenuse. So we want you to find the relationship between dm squared as well as le squared. And apparently, it must be equal to 13 over 9 lm squared. So let's see what will happen if I do that. I'm going to attempt to find the length of dm. dm is this line here. It is a member of the yellow triangle I just highlighted now. So I'm going to say, okay, fine. You want me to use dm squared is going to be equal to the bottom part there, which is kd squared plus km squared. This is from Pythagoras. So this is basically 2x squared plus the other one is actually 3y squared, which basically becomes 4x squared plus 9y squared. That is the first distance that is expressed in this thing that we need to prove. The other part is LE. Okay, cool. So now we are going to try and locate LE. Let's see where LE is. LE is this one that you are looking at right now, the one I just highlighted in red. The triangle that we are looking at there to figure out LE, it's LE squared, which is also the hypotenuse, is equals to KL squared plus KE squared from Pythagoras. So KL is basically 3x squared, and KE is 2y squared. Right. If you simplify this, it becomes 9x squared plus 4y squared. So we are required to add them. We are required to add these two, and the answer must come out as 13 over 9 lm squared. Let's see what will happen there. So I'm going to try to add them. So dm squared plus le squared equals to the first part, 4x squared plus 9y squared, plus the second part is this one, 9x squared plus 4y squared. Okay, cool. So what do you notice here? You will notice that the hypotenuse, the length of the hypotenuse is actually apparently appearing there. So that can be called ML. So we're going to use ML there. So let's see what will happen if I do this. It's going to be 4x squared. I'm going to bring 4y squared closer. And then I'm going to call this one LM squared because we already found that 9y squared plus 9x squared is indeed LM squared. But then if I factor out 4 here, I'll be left with 4x squared plus y squared plus LM squared. Now I can see here, I'm going to be a little bit sneakier. I can see that this x squared plus y squared is almost the same as the length of LM. It's just that it's missing a 9, which I'm going to introduce. So if I introduce a line by multiplication, I'll basically have 4 times 9 into x squared plus y squared divided by 9. I need to neutralize that since I did introduce it. And if you simplify this by multiplying in by the 9, you get 4 into 9x squared plus 9y squared, everything divided by 9 plus LM squared. And look at this, something nice emerges here. There's our LM again emerging there, which is quite awesome to see. So we end up with 4 over 9 LM squared plus another LM squared. And now this becomes a very simple arithmetic operation. It's 4 over 9 plus 1. Remember, there's an invisible 1 here even if it's not written. And if you add that, you are going to get 13 over 9 LM squared. So indeed, we have proved that the length of DM squared plus LE squared, DM squared plus LE squared is equals to 13 over 9 LM squared. That was an awesome question, a very, very involved geometry question that requires you to use your knowledge of the proportionality theorem as well as the theorem of Pythagoras. Thank you very much for sending us that wildcard. We are going to now go to an ad break. When we come back, we'll go straight to that Monica's question and use it to finish off the show. So don't go anywhere, stay with us.